Welcome to discussion 18. In today's discussion, we'll focus on section 3.9 on related rates and 3.10 on linear approximation. In this video, we will do a rotating laser example. So this comes from worksheet 8 and it's problem number 6. And the question says that a laser beam is initially pointing directly at a wall, making a spot. The source of the beam is 10 feet from the wall and is rotating at an angular speed of 0.5 radians per second. At the time the beam makes an angle of 30 degrees from the horizontal to the wall, how fast is the spot moving? All right, so I want to begin by making a note. So it's really common in these related rates questions to see wording of the form, how fast is something moving? Okay, it's also really common in related rates questions to see wording of the form, at what rate is some quantity changing? So if a question says, at what rate is some quantity x changing, that wants dx dt, the derivative of x with respect to time. And this derivative, when I compute a derivative, this could be positive or negative. If it was positive, that means the quantity x is increasing. And if it was negative, that would mean the quantity x is decreasing. But if a related rates question is worded in the form, how fast is something moving, then it just wants to know the speed. And when it wants to know the speed is not negative. So whatever we get for our value initially after doing some derivatives, we want to make our answer positive. Okay. The one kind of special exception to that is if a question says, well, how fast is something moving? And it specifies the direction, like if it says, how fast is it moving towards a wall or away from the wall? Then whatever direction it specifies, we want to think of that as the positive direction. Then it's actually a velocity question, and a velocity can be positive or negative. All right, let's get into this problem. I want to first give you 5 minutes to try it. 4, 3, 2, 1, pause it for 5 minutes to try this. Alrighty, so hopefully you've done that. Hopefully you paused it and tried it for about 5 minutes. Let's talk about it. So I'm going to draw a picture to get it started, and I want to draw it from top view. Okay, so we have a wall. So maybe I'll draw a wall like this. And then, so we have this wall. And some distance away from the wall, we have this source of the laser. So I'll draw a dot here, and I'll indicate this is the laser and this is the wall. All right, and it talks about the laser pointing at the wall, and when it does, it makes a spot. So maybe the laser is going to be pointing at some angle, and when it does that, that beam hits the wall and it makes a spot. Okay, so the question tells us something about the angle that's made by the beam, and it's measured from the horizontal to the wall. Okay, so the horizontal to the wall would be, so if I were to draw a line like this, horizontal. Okay, so this is the horizontal line that it's talking about. And I'm going to label that angle that's formed as theta. I want to assign a variable to it because that angle is changing as this laser beam is rotating. Okay, so there's one other quantity that's changing that I care about, and that's the distance from this perpendicular distance to where that spot on the wall is, and I'm going to call that x. All right, and the distance from the laser to the wall, that's given to us, that's 10 feet. So I'll just write 10. I don't need a variable for that because it's not changing. So we are ready to write down the rates that we know and the rate that we want to find. All right, and we know the rate at which this laser is rotating, so that's going to tell us d theta dt. It tells us it's rotating at 0.5 radians per second. So 0.5 radians per second. I technically don't know what direction the laser is rotating. So I don't know if the theta is increasing or decreasing. So I don't know whether the d theta dt will be positive or negative. So let me write a plus or minus. And it's plus or minus because the question doesn't tell us which direction it's rotating. So d theta dt could be positive or negative. We mentioned earlier that this question is going to be asking for the speed. So even if our answer ends up being negative at the end, we're going to make it positive. So at the end, this isn't actually going to affect our answer. We'll see that a little bit later. Okay, so what is it that we want to find? Well, the question says we want to know how fast is the spot moving along the wall. And for that, we are going to need to know dx dt. And we will need to know when our angle theta, it says is 30 degrees, so that is pi over 6 in radians. All right, so we are ready now to write down our equation. Okay, and I had forgot to mention this earlier, but this angle is a right angle, so we have this right triangle. And because we are interested in the theta, this angle, and these sides, the best equation is to use tangent. So tangent of theta is equal to the opposite side, which is x, over the adjacent, which is 10. And now I can take ddt of both sides. So ddt of tangent is going to be equal to ddt of the x over 10. So tangent here, let me rewrite x over 10 as 1 over 10 times x. That way I don't need quotient rule when I do this derivative. All right, so with implicit differentiation, the derivative of tangent of theta starts off with secant squared, because I take the derivative of the tangent. Then I have to multiply by the derivative of the inside, that theta, which is going to be d theta dt. That's equal to, on the other side, 1/10 is going to multiply the derivative of x, which is dx dt. Now we can plug in what we know. So we get secant squared of this angle, pi over 6, times d theta dt, which is either plus or minus half, 0.5 is a half, and that equals 1 over 10 dx dt, and I want to know dx dt. Okay, secant of pi over 6. If I use the unit circle, this is root 3 over 2, so I need to square that. And that's going to get multiplied by a plus or minus. Let me multiply this 10 over, and I'll get 10 over 2, and that equals dx dt. Okay, so if I square this, we get 3 over 4 times plus or minus 5 equals dx dt. So dx dt is going to be plus or minus, when I multiply, 15 over 4. And then I need the units. So on the top, I'll have the units of x. And the units of length in this problem, I think, were feet. Okay, and the units of time, I think I'll need those as well on the bottom. Those were seconds. Okay, so units of x on top were feet of the length. Units of t, of time, on the bottom were seconds. This is not quite my final answer, because remember the question asked, how fast is the spot moving? So I need to make sure I answer with the speed, which means I need to give a positive value for my answer. So the spot on the wall is moving at a speed, there's that keyword, at a speed of, and I make that positive now, 15 over 4 feet per second. All right, so in this example, it actually didn't matter whether our d theta dt was positive or if it was negative, because in terms of the speed, we end up getting the same value at the end.